Good morning from San Jose, California, home of GSD Automation. So today what I want to talk about is investigating the need for Scada or MES. And one of the things that is going on in the industry right now is with the industrial Internet of Things and Industrial 4.0, companies are pushing to digitalize, but sometimes the what and the how is hard to ascertain or difficult to ascertain. Um, in this presentation, we'll try to analyze the questions that need to be answered so that if an organization is deciding on getting a SCADA system, that they will be able to do some homework up front so that they could talk to their integrators in a manner that's going to be beneficial to them. So I start with Scada because Scada is the simplest. That is the lowest level on the factory information system as far as getting your applications or your assembly lines connected via network. So first off, let's address the acronyms. You got FIS, MES, SCADA, MHS, and I say blah, blah, blah because everybody's putting more and more acronyms out there. And I have mixed feelings about it. You know, some of these things have been around for a while. SCADA has been in use the whole time that I've been in my career for the last 30 years. Water systems have been using it. The oil and gas has been using it. Anybody that needed a remote terminal was getting data back to a central location for the purpose of giving you a bird's eye view because you don't have people at all these locations. An example is even with the railway, I used to do circuits for the telecommunications company, and sometimes we would have to wait a day for people to get out in the middle of Wyoming via a snowmobile to get to a remote site so that we could address a problem with a circuit. And that circuit would be on a SCADA system. Manufacturing execution system is related to your material handling. They can be separate, but a lot can fall in underneath what we are calling an MES because it depends on how you define it within your organization. And the same thing with a factory information system. You can put that at the top of the hierarchy, and then if you drew a triangle down and put SCADA at the bottom, then these other guys would build up on top of it, and at the base would just be your simple Ethernet IP network. The factory information system has a origination with Ford Company, and I put on here, at least they come up with the acronym. But these are one of the big guys that started this idea of a factory information system. Will it work in your house? I don't know. What do you have in-house? That is something that you need to go through and define or analyze what you currently have in-house as far as your network and your assets, what you want from an integrator as far as getting a factory information system or a SCADA, and then how are you going to engage in it or engage with that SCADA when you do get it. And this engagement thing is about the customer looking at what they currently have so that when you go to an integrator, you can ask the appropriate questions and be engaged in the design, because a SCADA system should be very personal to or customized to your needs as far as a corporate automation system. So if we look at factory information systems and some history with the buzzwords that are out there, Industry 4.0 is where we are now. 1969 is the time that the PLCs came about originally, and using electronics and IT for manufacturing applications. And as you can see, this is pretty much 50 years ago. We've come a long way, and this is the new thing at the moment. I'm not sure that it's terribly different than some of the things that we were doing 20 years ago. I remember going to my first ControlLogix platform specifically so that the guy that scheduled the lines could schedule his material, have control over it from his desk, and we put a simple, how do you call it, barcode scanner at the front end of the line to make sure that the operator was doing the schedule that we wanted. And so as far as industrial automation, we've we've been developing these things since 1784 on up to today, and it's expanding. So this should tell you that the buzzwords aren't always the most important thing to focus on, but more on what you need for your plant and what your plant objectives are. So what do you want to achieve with a Scada or with connecting your automation islands? How does that measure to you what you actually have in-house right now? Do you know what your assets are? Do you know your network components? And what is your cybersecurity threshold? So assets are defined as the people, computers, robots, program, logical controllers, historians, servos, and your camera vision systems. And I picked quality control systems. It kind of relates to the vision systems, but you may have a quality check in-house already as far as for your barcodes and your traceability. Those can be considered an asset because they may feed back into a PLC line, but they can stand alone as well. So if you network all these things together and allow the people interface, then you've got a bird's eye view of everything going on your floor. And this is just a more visual display of how that might help you. If we look at good industrial process, everybody that knows what a conveyor does will say that, an industrial process is a pull type process. So business-wise, everything in my mind is dependent on your output for your supply chain. So your customers would fall on this side, and your customer demand. So, and of course, it really goes in a circle, because what comes out of your plant and what comes out of your whole business system is contingent upon what is going into your plant. And we put the big word of supply chain on there because, it may or may not just be material. It may be something that's assembled at a different location. And in doing so, there's quality issues that have to be checked on before you use it in your plant process. And if you have multiple plants, you may have different plants that are doing different things. And number one example with that is the automotive industry and just in time, and the tier of suppliers that happens with automotive. And automotive has the ability to control a lot of what is coming in for supply chain. But the idea with connecting your machines together and having a firewall and being able to integrate with the business side is so that you can monitor this pull system as far as how raw material is coming into your plant and how it's going out. Because if you can get real-time data for safety, material handling, quality, scheduling, OEE, and operation costs, then you can affect your purchasing and planning, and you can coordinate with your customers so that you know what's going on in real time and how you're going to affect their business, and then also how they're going to affect yours as far as the supply chain issues. So if you look at a more detailed approach, and I have a link at the base of this, the end of this, that has some corporate guys talking about it with inductive automation as far as return on investment. And they actually have examples of the sales and marketing learning exactly the cost of the production of a part so that they know, how it affects sales. And this diagram explains more about the customer, sales, logistics, production, and development and purchasing as far as how everything is connected. And again, the customer demand is pulling it through the system. So understanding your connectivity between these different points of business allows you to know what your return on investment could be for a Scada system, and know what real-time data could do for you. For example, the Control Logics platform that I was talking about, allowed us to tell Ford that we were processing their product, and Ford could check on our website and find out when their product was going to be finished in our process. So then you can plan on shipping. So your logistics is directly affected. If we had any production problems, then the scheduler can notify, the customer interface so that they could automatically buffer that possible delay if it happened to go that way. So real-time data is important for the whole picture. If you look at your production and your plant and your product as a group of systems that are interrelated. And this comes down to understanding your operations. A lot of people that talk to me about Scada, they just think they're going to call up an integrator, and the integrator is going to come in and miraculously put this network together, and all of a sudden they're going to have data poof on their computer, and everything is going to be better. Well, Scada shouldn't be a cut and paste type of ordeal. It should be very dependent on your operations and what you need and what you're looking for. Otherwise, you may spend more money than what you need to spend. And you should be able to do it in a layered approach. So if your long-term goal is to have an MES, or if your long-term goal is to be able to track raw material costs all the way through the plant, then the first thing that you got to do is network your machines together and understand how your machines are using the material and understand what the waste is. So can you define your operations and your operations KPIs and how it relates to your automation, and pinpoint the tags that you want to bring to the surface so that you've got the data at hand in real time in your database at your keyboard touch that will show you whether or not you're meeting your KPIs. The other thing is supply chain. A lot of times, like for automotive, we had a supply chain issue where it was taking us 2 to 3 hours, sometimes a whole day, to go and find a problem at Forcia with our Nissan relationship. And Nissan would get unhappy that it was taking us so long to resolve a quality issue on the product. And so an end-of-line quality check was implemented, and then we used an FTP process to feed we were taking pictures, but we were able to feed those pictures back to a server, and then we created an application so that, once we took the pictures of the product before it went on the truck, we could show the status of what that product was before it left our facility. And once I implemented the application that allowed the quality people to look up the part number and to get the pictures online, it reduced their time of responding to Nissan, from, 4 hours to a day to, sometimes a couple minutes, sometimes a couple hours. And so it improved our customer relationship, and it allowed us to get a better quality score. That is your return on investment for networking your machines and for doing a Scada or having that IT OT interface between the business side and the operations side. So that's what I'm addressing here. A lot of times you get customer needs. You may not know where it actually is happening in the operations process, but with a Scada or a real-time system, you're able to see it. And when I say asset management, I'm talking about PLCs and robots. And a lot of people take for granted that those programs sometimes may change, and that program may be on an engineer's laptop as opposed to being on a server. If you have a Scada, you have the ability to put that software on a central location. You have the ability to secure that access so that only certain people are getting onto your PLCs or robots and changing the programs, and they're automatically updated so that any changes that go out, maybe for instance, a controls engineer could make a change today, get sick tonight, and maybe that change has an instance that causes a problem on the line tomorrow. And if they are still out and the other people don't know about it because engineers communicate so well, then there's nobody out there that knows where the updated file is and where the backup file is. But if you have asset management, then you're able to go and get the file and see the change and adjust so that you don't have unscheduled downtime. What I mean by skill set management is being able to see what your operators are doing and how that affects your product. Real-time SCADA systems allow you to see the buttons that are on. You can do logging. You can see what the speeds of the machines are, and you can learn, if I run at speed A, I get this kind of product. If I run at speed B, I get a different type of quality. And you can compare shifts so that you can better train your operators, and you get real-time feedback as far as what the deficiencies are. So things that I question when people ask me about a Scada is, do I need a Scada? Well, are you gathering quality data by hand, and are you analyzing it by hand? If so, yes, you need a Scada. How long does it take for you to know when there is a product quality problem? If you're not doing this in minutes or within an hour, then you're probably not automated to a point that you've got a good feedback. And then there's OEE questions. And if your OEE is not meeting your customer demand, then you are not utilizing your automation the way that you could. In my mind, this is my opinion, but so a real-time system gives you the ability to do that as well. And then the correct skilled people being scheduled properly, and then also operations-wise to meet your OEE. And that's, again, what I alluded to a minute ago for having the right people on the line at the right time, and then also getting the data, after the fact to the right people in a real-time scenario. If you answer no to any of those questions, then you need a better infrastructure. And infrastructure could be your network, it could be a historian, it could be adding to your Scada, it could be creating an MES, it could be adding to your system to allow for material handling or tracking, traceability, etc. I list these guys as the experts because these companies have shown on a regular basis, that they know what they're doing with their systems. And these are some of the big hitters. So there's documentation out there as far as what they've done. And I'm not into copy and paste things because a small business may not be able to size up or expand the same way that these guys have. And scaling is the proper word. So if you don't, then to me you start smaller, and it makes it more important that you figure out what you need for your system, in-house. And it's more important that you have that personalized relationship with an integrator that understands Scada and that understands more than just the buzzwords, but just how to help you digitalize. So the other question that a lot of people talk about, because I'll get asked, can I show a return on investment for a Scada system in 6 months? Well, it depends on how you use the system. And typically there's indirect returns on investment for Scadas. And it's some of the stuff that I've already talked about. And the real-time value, or the value, is the operational feedback in real time. Trend analysis is a big thing. At International Paper, we could predict how much chemicals we were going to use for the month, for the day, for the whatever time period. You could see it on a regular basis based on our trending using a pie system. That allowed us to take data and use justification of that data to get a better automated system so that we could save chemical cost. They were doing chemical samples by hand, and the operators were adjusting the chemical sampling, or they were adjusting the PID loops based on hand chemical sampling. So if you picture every 2 hours getting a hand sample and then making an adjustment based on that feedback, and compare that to if you have a sampling system that samples every 20 minutes and that you can make micro adjustments, or the computer can make micro adjustments in the actual automation system, then you can reduce your chemical costs a lot quicker, because you're not doing what I call the bathtub effect. Because for PID loops, if you're in the bathtub and the water gets cold, you turn on a whole bunch of hot water, and then it's too hot, so you turn it off, and so you overshoot. And that was the same idea that we were getting with the chemical use. And it also depended on operators and what their operational knowledge was. And so if you want more control over those types of things, then having a Scada allows you the feedback and the trending that allows you to put those things into place so that you can reduce operation costs. It also gives you the ability to see logs for operation decisions, and then also the how many times a valve may go out or alarm. So if you start getting a bunch of alarms in one place all the time, then you need to call a maintenance schedule and have a downtime to fix that valve or conveyor or motor or whatever it is that's giving you issues. So I put that underneath operational and maintenance, and quality control speaks for itself. Based on material handling and what you're getting out to the customer. For instance, with seats going to Nissan, if we're getting stitching issues or burns on the seats, or something's not being bolted down at the right torque, we should be able to get back into the system and see what the torque values were, or look at the pictures of the seats going out. And then reduce risk based on asset management. This is related to downtime and disaster recovery. I mean, if a PLC conks out and you don't have a copy of of the PLC program, then you're at a risk. If you look at Rockwell's product for asset management, it's roughly, or it used to be $40,000 for the software and for a license, and then of course it's dependent on how many PLCs that you have out there or how much you want to store. But that was enough. One license for us was enough to cover one of our plants, and it's worth it when you have a changeover with controls engineers, or if you have older PLCs and you don't know when those PLCs are going to break down. So the other side of this for Scada is understanding your industrial, how you're doing your industrial process. This is why I'm saying that Scada is customized for you, or it should be customized for you, because things may be different, or different priorities for you if you run batch, if you run islands of automation, or if you have continuous lines, if you're 24/7 as opposed to 2 shifts. All these come into play, so there's no one-stop shop for Scada MES. And, don't be pulled into the acronyms. Look at your own system. Look at what good practices are based on what your company needs are. Some of the buzzwords out there are overwhelming to me, based on being in the business for a while. And I remember a conversation with a man that worked in the glass industry, and his plant or his company made bottles for Anheuser-Busch. And, they were in rural areas, and it's a glass plant that uses, they would do the recycled glass, and they would also do the new glass, and then bring it together, and they melt down the glass product. And I don't know the whole process, so forgive me on the words, but they melt it down and then making the bottles. It's an old process. It's not the most fancy process in the world. It's very dirty. It's very hot. But he had people that were there, union, 20 years, whatever. So if you come in with these buzzwords and acronyms and blah, 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 they look at you like you're crazy. And so what he did for Lean to help out his shop was he knew enough about what he studied on Lean and what he had learned to correlate it to the words and the descriptions that they knew in-house, and talk to them on a level of what I'm calling personalized here, or customized, and have the same meanings or have the same outcomes, but not all the fancy words. And with that in mind, he was able to, 1, get people engaged, and then 2, get better production with better quality, and allow people at a lower level to have accountability. And to me, that's something that you can do, or that comes as a indirect result of a Scada MES system, because people start looking at the data and they start knowing how their machine works, and then if they know how to fix it, then you've got less maintenance calls, you got less problems that are going up the chain, and they're taken care of sooner. And the same thing with talking to your integrator. You need a relationship with the integrator for a Scada MES. You need to understand the requirements that your company needs for their operational KPIs, and agree upon how many tags that you want to look at, because you could spend the money to bring in 3,000 tags, but you may only need 30 tags from each machine. And the difference is, data-wise, it costs money to have the space to save it in your historian. So those are all things that are going to affect the cost of a real-time feedback system on your automation. Also, whether or not you use servers, edge computers, or cloud data, and all those things need to come into play for what your company needs and what you want the outcomes to be of a Scada feedback system for your automation. And those are the things that you need to think about as far as having the conversation with the integrator to get a Scada or to digitalize some of the automation that you already have in place. So, in conclusion, if you don't have your automation lines currently connected, or if you need something else, then note what your assets are. Note what you want to do with the data by connecting your machines, and then compare what you want your outcome to be to what you have now. And if you're doing a lot of things manually with paper or Excel spreadsheets, etc., this is your indirect ROI, and it may be based on time. But it's costly if you're having somebody go through the data and populate an Excel spreadsheet by hand. If you could do that with a database output from a historian, and save, if you save 3 engineers 2 hours a day times 365, then you get your return on investment, because that gives them time to look at actual problems as opposed to doing data for the management meeting. And lastly, decide on the infrastructure that you want to go to get you there. These are my references. Inductive Automation has a video out there with some of the C group people, and I pulled in this sheet from Murata because they're talking about the difference in the industrial process, and the differences between cell production and continuous or a long production line.